Today we're starting 4.1, minimum and maximum values. We need our calculators. This is one important thing we need to be careful of. Is the 0 less than or equal to x less than or equal to 1? That is the only spot I am looking at on the graph. So in your calculator, type in x minus x cubed. But I need to change my window. I'm going to change it back to normal. I need my x minimum to be 0. I need my x maximum to be, whoops, you need to change your min and your max. I graph. It didn't show me much, right? There's a reason why. What didn't I change? The y's. You might have to go in and change the y values. It looks really squashed, right? So I need to make the window bigger. So instead of being from negative 10 to 10, let's try, give me some numbers. Now, you don't want the window to be so big, you want to actually zoom in more. Negative 4 and 4. Now I graph. A little bit better. Yeah. All you're doing is changing your window. The first time we were zoomed in so much, now we're just zooming out a little bit more so we can see it better. I just went from negative 1 to 1 to see. Looks better. I am only looking at the graph from this part. We want to know what's the maximum value in just this region. How can I find the maximum value? Second trace 4. I need a left bound and right bound. I know it's in between negative 1, or sorry, 0. Put my left bound as 0. My right bound is 1. I know it's in between both of these. I don't care what the guess is. Press enter. My maximum's at 0.577, 0.385. Yeah, it tells you both. That's my maximum value. The max-min theorem. It's just putting it into words. Let the function f be continuous on a closed bounded interval. We just looked from 0 to 1. That was a closed bounded interval. You might have, then you have a maximum and a minimum value on AB. There's always a maximum, there's always a minimum. Looking at the graph, you only see this maximum, but there is actually a minimum there too. What's the minimum? If that's the max, the lowest it ever goes is at here and here. So if I just traced What's my minimum at? My min is at 0, 0, and there's also one. Whoops. It's going to be 0, not 0, 1, 1, 0. There's always going to be a max, there's always going to be a min. The max we already said was the 0.577, 0.385. What all three of those are called, those are my extreme values. Suppose C is an interior point of an interval I, and f of C is an extreme value of f of I, or sorry, value of f on I. If f prime exists, then f prime of C is 0. Write it down, I'll show you some examples. Find all the extreme values for f of x equals x minus x cubed. Without using the calculator, this is what we're going to do. We're going to find the extreme values. Take the derivative of x. One minus 3x squared. Now what this was saying is taking the derivative and setting it equal to 0. So it's going to be 0 equals 1 minus 3x squared. What do I need to do first? What would the 1? Add the 1 over to the other side. Or subtract over, sorry. My equals look like a minus. Subtract it over. Now I need to divide by 3. So I have, or divide by negative 3. 1/3 equals x squared. Take the square root. So x equals plus or minus the square root of 1/3. Now what we're going to do is put them into the original function. We have this one, and we have these ones. Your endpoints are always extreme values. So I have f of 0, f of 1, f of the square root of 1/3, and f of the negative square root of 1/3. If I put in 0, 0 minus 0 is 0. If I put in 1, 1 minus 1 cubed, 1 cubed is 1, 1 minus 1 is 0. Now let's put in the square root of 3. And I'm just going to put it right into the calculator. Square root of 1/3, sorry. So I have square root of 1/3 minus the square root of 1/3 cubed. And I get 0.385. Now I'm going to do the same thing, but with the negative. instead of retyping everything, second enter, go and put in a negative. I put it in the wrong spot. Okay, negative square root of 1/3 minus negative square root of 1/3 cubed. Enter. I get negative 0.385. What do you know? What are my minimums? My minimums are at 0 and 1. What's my maximum at? Square root of 1/3. The y value. Sorry. I'll show you. Square root of 1/3. Square root of 1/3 is 0.577. So I have a minimum at 0 and 1. I have a maximum at square root of 1/3, which is the 0.577. Now my question is, why didn't we look at this one? There's a reason. What is this telling me? What is that negative 1 square root of 1/3 standing for? Standing for my x value. What do I know about x? It has to be in between 0 and 1. So right away, we'd even have to do that one because it does not fall into my region. Do you understand how to do the max and mins? Doing it with derivatives, not just the calculators. My max was the square root of 1/3. I have mins at 0 and 1. I have a max at square root of 1/3. Okay? Please don't. That right there just tells me you did it the pre-calculus way of the max and mins on the calculator. We try to leave them as square roots and radicals and all of that. Try this one. I have got to find the extreme values for g of h equals the square root of 1 plus h squared, and I'm looking on the interval of -2 to 3. First thing I need to do, take the derivative. So g prime of h. This right here really means 1 plus h squared to the 1/2. So I have a chain rule. A is going to be 1 plus h squared. B is going to be h to the 1/2. The derivative here is just 2h. The derivative here is 1/2 h to the -1/2. I replace my h with 1 plus h squared to the negative 1/2. Which, when I multiply this and this, what's 2 times 1/2? 1. I'm just left with h times 1 plus h squared to the negative 1/2. I set it equal to 0, and I solve. Now, out front, 2 times 1/2 is 1, and h times, remember you have to take the primes and multiply them. I don't want to leave it to the negative 1/2. What do I need to do? All right, I didn't want to leave it to the negative 1/2. I'm just going to show you what the graph looks like. Square root 1 plus x squared. My window needs to be from negative 2 to 3. I don't see anything, right? So I'm too zoomed in. I'll change my y. Let's go negative 5 to 5. What happens? I have an extreme value here, an extreme value here, and a minimum here. What is that value? 0. If I look back to here, how do I get this from the bottom? Multiply it. What's 0 times that? 0. H is 0. That means I have extreme values at 0, negative 2, and at 3. So I substitute in g of 0, g of negative 2, g of 3. And I'm going to use the calculator because we need time. I already have it typed in. Second table. 0 is 1. Negative 2, actually let's do 3 because it's right on the screen. 3.16. Without using the calculator, I would have had a radical. Negative 2 is 2.24. Why is it 1? At 0, it's 1. Okay, if I look at the graph, at 0, what's my y value? 1. This means I have a minimum at 0, a maximum at 3. That negative 2 is an extreme value, but it's not a max or a min.